I was gonna slash you turning right here.
Good morning.
Good morning. So my thing is, I thought I needed try and catch until I started using it across multiple options and catch players.
Okay. Is there anything else anyone wants to chat about office hours today? I got 2 requests. I didn't see if I might have missed some in the channel, but I think this is all I found was call stack in the channel.
What the differences between defining variable normally and defining variables
Inside of curly braces? Got it. So you want like the JavaScript block syntax, okay? We can talk about that. Any other questions? What are y'all working on? Anybody struggling with anything? You were call stack, right? Yeah, cool.
I'm struggling with CSS media query.
Sure. Yeah.
I will reinstate it in this.
Theory?
Like, or theory testing theory. Like, well, I guess just walking through, like, all right, so I'm gonna make a program that does this. How do you think about like laying out your test for this? Or, like,
Sure. Okay. I'm just gonna call this TBD. Cool. All right. Let's dive into some of this stuff. This block syntax one, and then we'll do this one, and then we'll do this one. Okay. So this is a newer feature in JavaScript, which I actually probably should use more than I do. This has to do with so in ES5, we only way to declare a variable was to do var like that. You could omit the var, which would give you a global variable no matter where you did it. And then you could also, there was this other way where you could define a variable by declaring a function with this syntax is similar to saying like var thing equals, right? So these were the ways that we used to define variables, and we had the global scope and then lexical scope inheritance via functions, right? So these are going to be, and just to be clear, this file that I'm writing, this example code, think of this running in the browser. It's a little bit different when running in Node, but let's say we were going to run this code from a script tag in the browser. It's going to, these 2 variables are both going to be global variables. But if I were to come in here and put another variable, right, we could console log name and color, and we're going to get Jared in blue instead of Jared in red, right, when we call thing at some point, okay? So this was a way for us to have global variables and local variables, and then in later versions or more recent versions of JavaScript, we added we added let and const, which work in 2 different ways. So one of the main differences between let and var, which are pretty much the same thing, they just declare a variable that is mutable. Right? So we can come in here later in our code and say that our color has changed, and that's okay to do with var. It's also okay to do with let. We could do the same in all cases where we use var, we can use let. But let has this additional scoping feature. So for example, you might have all seen this very common, my editor auto-generates it, like a standard for loop. So let's say we had an array of colors. This would be a standard, whatever. Oh my God. Okay, so if we had an array of colors, this is a standard for loop. So when I do var I in this for loop, var does this thing that you might have read about called hoisting. And what that means is anywhere in our code, if we say, if we declare a variable down at the bottom in here, when JavaScript interprets this function, it sort of reinterprets it as if you had taken all of these vars and hoisted them up to the top and just said that they were declared. And that's what it means to hoist, is that it takes any variables declared within the function, and the first thing it does is say, okay, I now have a local variable called that. So it does that first. And let does not do that. If we were to console log name and color here, we would see that color was this global variable. And let can be declared at runtime, and we can override that variable, whereas we had access to the global color before and now we don't because we overrid it. And this new local variable that overrides the global local happens at the time that we call let. That's one main difference. So no hoisting for let.
Because color was declared as a global variable, does declaring color in the function actually overwrite the global variable?
No,
Okay.
no. And I want to make sure I'm right about this. So let's come in here and we're going to say let color, and then we're going to say const log color is a function that just console.log color. And we should see that this says, oh, I have to actually call log color, and we see red. Okay, and then if I come in here and I say let color equals blue, I'm so afraid I'm going to be wrong about this. Okay, so I am a little bit wrong about this. The way I described it earlier wasn't exactly accurate. This, see how we get this error, colors not defined? That's coming from line 4. Is that right? Yes, line 4. So we still, okay, so it's actually kind of half and half. It still denies you access to the global variable, whereas if we just had this, like, it's fine. But if we at some point later declare color, we still get color as part of our local variable, but it's not declared. It's sort of half declared. It's sort of in our scope, but it's not defined yet. So we get this error saying, like, you tried to use a variable that wasn't initialized yet, that wasn't set up yet, right? So that's one main difference. If we change this to var, it's gonna log color undefined and then color blue.
You get the same error if you remove the let on the first line. Make that a let, and make line 5 a let, and just remove let from the line 1.
Make line 5 a let and remove let from, yeah, I think you should get the same error.
Why did you get undefined blue when that was?
Yeah, let me go back. So,
that's what I was gonna ask.
yeah,
I
so
thought it was gonna be hoisted, didn't it?
so the hoisting part is just this.
Right. Oh.
It's the hoisting. There's a difference between declaring that a variable exists and saying what its current value is.
Gotcha. Okay.
Okay, so let's look at this in the browser, and we'll look at it in terms of, there's a nice visualizer in the browser. So I'm gonna make this a little, let's just do this. I'm gonna just take this into a browser window, and we're gonna run this, and we get that same output, right? So it's undefined. Oh, I actually don't want to explicitly do this. So color is declared, the declaration is hoisted to the top, but the assignment is not. So we get undefined and then we get blue. Let's throw a debugger in here. Let's throw a debugger here and a debugger here. And so it's a little wonky because it's so big, but is this still readable for everyone? Yeah? Okay, so we're pausing the debugger here, and what I wanted to show you is on the right-hand side, you've got this scope drop-down, and it shows you a ordered hierarchy of sets of variables. And you can think of variables as keys and values. They're kind of like, this is sort of almost not true, but they're kind of like an object, right? It's got a key with a value assigned to it. So they use that sort of shape to display this to you. locally we have a variable called color, and it's undefined, as it is when we're paused in the code right here. And we also have this, which is another special variable, right? So that's what's in our local scope. And then our parent scope is the actual full outer scope here, which has color red and log color, which is a function. And then on top of that is the global scope, which has everything global on it, okay? So you get this little visualization of like a scope that inherits from a scope, that inherits from a scope, and that can be fairly deeply nested. And if you're having trouble realizing where a variable came from or what scope a variable was declared in, this visualizer using the debugger and the Chrome Developer Tools is like an awesome way to visualize that. Cool. So let's see what happens when we change this to let. And I know this is going to throw an error, so I'm just going to remove this line. Oh, well, before we do that, let's hit play. And now we're in the debugger 2 lines down, and we just see like our local variables now been assigned to blue. That's the only difference here, right? So let's run some different code here where we use let instead of var. And you'll see here, we still have color. Oh, well, that's a little wonky, ain't it? Because it said color was not a thing.
I think it said it's not defined before.
It did. It certainly gave us that error before. Let's try it again. Yeah, color is not defined. This is really interesting. So I've walked through this before, and I was overly confident in how much I understood this, because this is not what I'd expect to see, right? Because the very next line of code, if we hit play, is going to give us the error that this variable isn't defined. So there's something to dig into here, where to play around with let and var. As I'm trying to describe this to you, I'm finding exceptions to my understanding to it, which is fine. It doesn't mean we don't need to fully understand these things to use them. So some takeaways that are useful for me is I just use let and const for everything. I don't use var anymore, and I just don't rely on hoisting. So if I was going to write some code like this, I wouldn't write it like this. I would put this up here. Or if I needed this order to matter, I would declare color first, and then I would later do this. So I think using let and const have a different, they certainly work different than var, and they're meant to be sort of a stricter sort of improvement on var. Yeah.
I was asking actually about, sometimes you see.
Yeah, I know. I'm driving toward that block syntax thing. Yeah, cool. I just wanted to like prime this with like this idea that we've got these scopes, and a function is a way for you to get an additional scope. So if again we were writing this code to be run in the browser, we don't want to declare like here's my button, which I'll get from a document query selector all. I can't type, but you know what I'm saying, right? We don't want to declare global variables here. So a lot of hopefully everyone is familiar with this with the concept of an IFI at this point, where we create ourselves an immediately executing function just so that var is not a global variable, right? So we can run this code. And button will not be a global variable. And in recent versions of JavaScript, they have this thing just called a block, which just does that. So if we were to write some code that would be like name equals Jared, and then a block, and say, oh, why am I using var? Let's just use let, and we'll say let color equals red. Console.log color down here should throw us an error because we've created just like a block. And then we have local variables, and that local variable should only live inside that block. So let's make sure I'm right about that. And there we go. Color is not defined. So this is just a way for you to it's a new syntax for what an IFI was intended for before, which was like just give us a block, give us a scope. Yeah.
Why is color not defined?
Because this is a local scope. So let's use debugger again to visualize that. And here we'll visualize it 3 deep even. I'll put another scope in here. Reload the page here. So here we are in a block scope, which has color in it, and it inherits from the outer scope, which we declared name, and then that's declared from the global scope, or that's inherited from the global scope, right? So if we play again, now we're in a block inside of a block. So it's just a block is just a space for you to have a lower scope, a scope that has its own local variables, that when that block completes, those variables go away. Yeah.
So I'm wondering, seems like the node module PG in the docs, it says const, and then it gives you a block, and then capital client equals require PG. So it uses this technique.
Can I see that code? Can you send that to me? I don't.
Just when you're creating your client, it like says to do this.
That's not a block. That's destructuring. That's different.
Okay.
So this. So what the question was is this a block? When you say const URL equals require URL. This actually, I just read the docs for URL. This is from the docs. You might expect this to work just like FS works, where you say I want FS, so require FS, right? That should be straightforward. Line 2 is a little weird, and line 2 is using destructuring. And so what this is actually doing under the hood is it's saying, it's storing this in a temporary variable, and then it's saying URL equals temp.url. So this is just saying whatever object comes back from require, take whatever property is here and make that a local variable. So let me show you destructuring. So forget the require part because that complicates things. Let's look at it in here, and I'll show you a literal version of destructuring. So let's say we have an object. Let's say we have a person object, and it's got a name and a size. Okay. So here's our person object. I can say const name size equals person. And what this will do is it will create a local variable called name and a local variable called size, and will assign the values to whatever the matching name properties value was. So we'll get name is Jared and size is, oh no, name should be Steve.
Is it because it's the browser?
It might be because of the browser, but it should still work. It might just be because we're in the console here. Let me try this again. Here's person. It might be that the browser doesn't support destructuring. So destructuring is a new feature of JavaScript, and it's not supported everywhere, and it actually might not be supported in the browser. I actually never used destructuring without transpiling with Babel. So Babel is that tool that will turn newer code into, there's already an example here in the default code that they showed us. So it's going to do, so this code that we're seeing here is an example of destructuring. We need these three functions from this file, right? And this file returns an object that has these things on them, and we use the same name variable as property to generate these. So that's destructuring. What's up?
As opposed to the module exports. Is that just a different
module? No. So utilities is going to be. So to do this destructuring, to get A, B, and C from utilities, inside utilities, it's doing this. It's saying like module.exports equals, A, B, and C from up here, from being defined up there, right? That's a common pattern. You could also just do module exports.A equals, B equals, and C equals, right? So it's just defining properties on an object.
What was the window that we were looking at on the right side?
This?
Just out there.
This is just what the new version of JavaScript gets translated into the old version of JavaScript. So the code that you showed me was something like get the PG object from the PG library, right? And what that means is the PG library returns an object that has a property PG, and we want the same named variable. This is just a way for you to easily export multiple things and import multiple things from a file. So I can make a file that exports functions A, B, and C, and then I get local variables A, B, and C. So that's destructuring. That's different from that block syntax. And what you're noticing is curly braces are used for a lot of different syntaxes, right? They're used for functions, blocks, objects. They're really overused in the syntax. So you want to be able to see the difference between an object versus a block, which has some code in it, versus a function, which has curly braces, right? There's these three different syntaxes where curly braces wrap around something and they mean very different things. So does everybody understand these three differences, or do we have questions about these to get more clarity?
Line 7 through 9 is an iffy.
Kind of. You can think of it as an iffy. Yeah, it's just a local scope. Yeah, it gives you the option to just have like a local variable. You know.
Yeah, what I don't understand is why can't you say print or console.log I on line 11?
Because that's the whole point of a block, is that variables declared inside of this block only live inside of this block. That's the reason we would use a block.
I would think we'd use a block to prevent, like, if I had another I outside of the block, I don't want them to, like, collapse. I think my understanding was like that I was using iffies to like not pollute the global scope, right?
Yes.
But if I do declare something inside an iffy and I'm running that right away, I would think that I would be able to print I, because like that's kind of like I'm out. It's like I'm using a variable outside of the function.
And you can't do that. You cannot access a variable in a higher scope. You can't go down in scope. You can only go up in scope, right? So a scope, when a scope is created, like it is in this block, or like it would be if we ran this function, whatever, right? When this function runs, you get a local scope. So if I were to put a for loop in here with an I, you know, stuff, it doesn't matter what we're looping through, right? If we have this I variable here that I'm only using whenever you call whatever, it should not be accessible out here. I should not have access to I here, because I is only specific to the current, or to the instance of whatever being running, right? Does that make sense?
Yeah.
So just like running an iffy like this, or here, we might as well put an iffy on the screen just to talk about it. Right, these are essentially the same, and I wouldn't expect to have access to this variable anywhere else outside of these curly braces. Or same thing here. I remember you had your hand up.
Well,
So,
that's
but I want to.
question.
Okay, yeah.
It was just if an iffy is synonymous with what we do.
I think so. There's probably some subtle edge case differences, but the intention is the same, which is to just go down in a scope so you can have local variables that don't pollute this whatever scope you're in.
Yeah, it doesn't interpret trying to make an anonymous object literal.
It does not interpret this as an object literal. Let's see what Babel converts this to. It doesn't. So it looks like that's just supported. Because if we just go into the terminal here, we can say like and we know maybe I don't know what I'm talking about. I'm not. This is like the worst. Let's do it in Node, because I've done this in Node before, and there should not be an I here. Let's find out. Maybe I'm totally wrong about blocks. I've rarely ever used blocks. I use iffies for everything, and I usually don't use the features that I don't know for sure are well supported. So forgive me if I'm giving you wrong information about this block thing. Let's figure it out together. Blocks, what now? So we should get an error trying to log I here. There we go. I is not defined. So if we did have an I out here, we should get 10 and then 45. This is how I'm used to shit working. The browser is behind in, well, it's not even really behind. It's such a mess. The features that are new to JavaScript are just, there's a pile of them, and Chrome has some subset of them that they've decided to implement, some versions of Chrome. Some versions of Node have different parts of them. And there's like these, and if you need to know, JS block, how about JS feature support graph, maybe, or matrix. Here we go. There's a couple of these that folks have tried to compile together, but block, is that in here? Here we go. Block level function declaration. What is that? God.
This stuff gets like gets decided to be standard at some point. When it comes to implementing it in browsers,
yeah,
are they trying to add in what's most reasonable, or is it like basically what whomever is working on the browser sees most?
That's a really good question, and it's actually really complicated. So I read in a newsletter yesterday that for the second time, the people who are in charge of Node and its development are not being as responsive as the community of developers wants them to be. And so there's been, like a year ago or so, someone forked Node and they built they went off in their own direction, and they were like, we're going to take Node over here and build it this way. And eventually they were like, all right, let's just merge these things together because we don't want two nodes. And then this is happening again. Another group of people's like, y'all aren't doing a good enough job of what we want, so we'll fork Node and develop in our own direction. And so like, it's a complicated people problem, right? There's people who are somehow in charge of what gets added to Node and what doesn't. Same thing with Chrome, although Chrome's owned by Google, so like, whatever the Google developers want to implement / are allowed to implement. I really honestly don't know the politics going on there. I'm sure that there are open source or open email threads and things that you can look at if you really wanted to know what's the cutting edge of what's going on in the Node community and why some features are supported, or why import and export isn't supported in Node is probably a pretty good debate that's been going on in that community, and there's probably some good reasons or some silly reasons why they haven't switched, right?
So like a mix of like political and technical reasons.
Totally, yeah. It's really hard to keep politics out of stuff when there's people involved. So the short answer is I have no idea, and I'm not even fully certain what features are supported where. And when I want to use a feature, I just every time I test whether or not it's working in the environments that I care about, or I use something like Babel to transpile to some code that I know works the way it's supposed to. But you can come in here and you may or may not have different success finding what you're looking for, but certain things like, can you define a class with the class keyword, right? That's supported by Babel transpiling, by Microsoft Edge has support for that, but whatever the heck these other things are, like older versions of Node. Yeah, Internet Explorer 11 is the end of life of Internet Explorer, right? Microsoft replaced it with Edge, so it doesn't have support for a lot of these things because nobody's working on it. And so like, there's other collections of this data for you to look at. There's also caniuse.com, which is a great resource of like, can I use media queries? Can I use Flexbox or Grid? And it tells you like, okay, someone running an old Chrome isn't going to have Grid, so you got to be aware of the implications of that. So forgive me for not fully knowing how block works, and the fact that it doesn't work consistently is a problem in the JavaScript world. So you can read about these things, but you're going to have to dig a little deeper to find out if the more newer cutting edge stuff is actually in the environments that you want. So like, I'm running, I think, a pretty latest version of Node, like 8.1, but I know some other people here are running like 6 and 7, so your mileage may vary depending on what version of Node you're using. So if you want to play around with getting the latest version of Node, you can get NVM, which is a Node version manager, or you can also just like use Homebrew to upgrade Node to the latest version.
I know in
Chrome developer tools, you can like play around with different devices. And
Yeah.
Show you what this would look like on
Yeah.
Nexus 6. Is there a way where you can do that for different browsers? Like show me how to render it and explore it?
Man, that would be an amazing tool,
Right,
but
like, I feel like it'd be pretty process intensive.
no, unfortunately, I don't know of any tool that does that. The closest thing you'll ever get to, not ever, but the closest thing I think you'd get to now is running multiple virtual machines in something like VirtualBox to get like Windows XP, Windows 7, Windows 10, Windows 7 with IE6, or Windows 10 with IE9, or what, like all these like million permutations of browsers and operating systems. Like there are many companies whose whole job it is you say, here's a URL, go to it in 25 virtual machines and take a screenshot of what it rendered as and send it back to me so I can know if my like Flexbox grid worked in all 75 permutations of things I care about, right? So if you work at like LinkedIn, you're going to be doing this kind of, you or someone is going to be doing this kind of QA to figure out that there's like maximal support for whoever comes to this website. But if you work for like GitHub, and they don't give a shit about Edge, right? They're like, if you're running Edge, whatever, it's your problem, right? So that may or may not be true. Don't quote me about that. But essentially, there's varying levels of support that your company and a lot of companies, if they're really thinking about this, will have a fixed set. And so you'll know as a developer, you must work in these environments. Some companies are like, we hope it works in IE, but nobody really checks.
And some web pages you come up to, they're like, hey, this is intended to run in these 3 browsers.
Yeah,
Do
yeah,
you want to continue?
yeah.
Like,
Yeah, and however annoying it might be to find out that things are as dirty and mucky, God, man, it's so much better than it used to be. You just know that it was a million times worse, and just be thankful you'll never have to use Internet Explorer 6. Still traumatized. Cool. So I think that's a lot of time we spent on blocks. Let's do some try catch stuff. Yeah. All right. You said you thought you understood try catch, and then you realized you didn't.
So the problems I was running into, I was doing the command line to do this, and I was throwing an error if the command I put in wasn't correct.
Uh-huh.
So that was working. And then in my delete and complete files, I was throwing an error if the person didn't put a number in after delete or complete
Okay.
for the ID. And I was throwing an error there. And what I realized was happening is I was throwing 2 errors, like both of my errors were getting caught in my original catch block.
Uh-huh.
So I was working that out with Thai, but I guess I realized I'm a little confused about how errors that are thrown get caught in where and
Sure. So this is going to dovetail really nicely. So I'm going to do both at the same time as best I can to talk about the call stack and try catch, because you need to understand the call stack in order to understand try catch. So let's do that first. Let's talk about the call stack, and then we'll throw some errors and watch it run around the call stack. So
Since we're here, can we also talk about rethrowing an error? What does that mean?
right at the end, remind me to talk about rethrowing, and we'll do it. So I'm just creating a series of functions here that are just named in sequence, and one is just going to call the other. So function A is going to call B, which is going to call C, which is going to call D, and D is not going to do anything. So I'm going to start out this chain by calling function A. And then when I get here, I'm going to go in the debugger. So I'm actually going to set this up to run in the browser in a way that I don't have to. God. Okay. Here we go. Okay. So this is just an HTML page that's loading this JavaScript. And so what happened when I ran this was it ran this code, right? It logged function A, B, C, and D. So we started here. We went to line 1 and it executed line 2 and then we executed line 3, which got us to line 6, and then 7, which got us to 10, and so on. Everybody following that? Okay. So because we have functions calling functions calling functions, we have a stack of calls. And if we look in the Chrome Developer Tools, it gives us this nice visualization of the call stack. So we can see that anonymous was line 18. So there's just no name for this. It's a file. They probably could have called it try. I mean, they do show you what file and line number, but like I'm not sure what would be a better name than just like anonymous. So we start here, and then we get to here, and then we go to here, and then we go to here, and we go to here. And we can actually, because I'm in the debugger here, we can actually walk up and down the call stack. And well, what does that mean? What does the call stack mean? So if you picture a normal, if you picture any program, right? Programs are going to have some starting point. Let's just say that's the top of some file, right? We're executing a file. And then we call a function. And then it calls a function. And then that function completes, and then we're back down here, right? So let me try to visualize that. Instead of using just A, B, C, and D, let's put a couple intermediary steps in here. Let's make a B1 that doesn't do anything, and we'll make like a B2 that doesn't do anything. And we're gonna put some debuggers in here. Okay, so we started again down here, function A, ended up calling function B, and function B called function B1, and then we're here. So here's their call stack. It's 4 deep, okay? And when I hit play, we're going to return from function B1, and then we're going to end up back here and go down to line 8. So I'm just going to say step into the next call, or I'll just hit play, and now our call stack is function A called function B, and now we're in function B2. So you can kind of visualize this. I'm going to try to use this drawing thing. You can kind of visualize this as like I try to visualize it as like a mountain range, right? Where we have like a function calls a function and calls a function. So we're kind of going deep in this call stack. This calls a function, and then this calls a function, and then sometimes that function comes back down, and we call another function, which calls another function, and then that returns, and then we go up again, and then we come back down, and the call stack is kind of like a function calls a function that returns, then we go up again, or rather down again. So think of this as upside down, right? We go down the call stack, and then we come back up, and then we go down to do some more work, couple functions, call some other functions, and then those return, and then those return, and we're kind of going down and up and down and up, and we kind of walk this mountain range of call stack. Does that analogy help at all? Does that make sense at all? Okay.
There's also an upper limit of how many stacks you can have, because sometimes you get...
There is, yes. So there is a limit to how deep the call stack can go. And this is to prevent recursion from going out of control. So if we have, we'll get a little simpler here. We'll just say bad recursive function is a function, right? If we imagine a function that just calls itself, right? This is an endless loop now. Okay, so bad recursive func is going to call itself, and then it's going to call itself, and that's going to go on forever, and we're going to get a nice little error if we ever called it to begin with. We'll get a nice little error called maximum call stack size exceeded. Okay, and that's a protection saying that you really shouldn't be writing your programs to where the call stack just keeps growing forever, because each time we have something in the stack, we're holding memory for any variables that might have been in there, right? So if every time I say const thing equals something, right, this data gets put into memory and it stays until this part of the call stack is returned. Until we return from this function, that memory stays around. So as the call stack grows, our memory usage grows, and we have a limited set of resources there. So there's a maximum size to your call stack. That size might be a memory limit, but it might just be a hard number, like you can only go 1,000 deep or 10,000 deep, right? But regardless of there being a limit, let's do this. Let's make a not shitty recursive function. So we'll say go until 10, and we will say n, and we will start with 0, and we will say console.log n, n equals, and then go until n is n plus 1, and we'll say if n is 10 or is less than 10, then we will call go until 10, and we'll return that. Otherwise, we'll just return done, whatever, right? So this is a recursive function that we will continue to call itself until n reaches 10, and then we will do nothing, right? So let's run this, and we'll just see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if we come in here and say, we'll put, just after we log, we'll put debugger. So now we're in debugger, and look at our call stack. Go until 10 is just 1, and the value of n is 0. And then I play, and now go until 10 is now twice in the call stack because it called itself, and n is now 1, and now n is 2, and n is 3, and we can watch our call stack grow until n gets to 10, and then we reach our exit condition, and every single one of those things returns out and goes off the call stack. Yes.
Something that I find confusing is that stacks, as far as the data structure go, are supposed to be first in, last out. Queues are first in, first out. I'm pretty sure I'm getting that right. Right? First in, last out is what a stack is supposed to be.
Yes, and no, a stack is first in, first, or last in, first out is a stack. A stack is like dinner plates. You take them out of the dishwasher, you put them on top, and then next time you go to eat dinner, you take the ones from the top, right? So it's the most recent one that you put in is the one that you take out.
Yeah, so I didn't say it right, but so
yeah,
last in,
first out is a stack, yeah.
So if you're going through a page of functions, and the first one on the page, the first function on the page is the first dinner plate you put down, and then I guess the second function on the page is the next one.
Well,
so
there's no
run before the first one.
Yeah, so the call stack and the order at which you defined functions isn't really totally connected, right? Like I can come in here and define a function up here or down here, and it's not really relevant to the call stack. That's because these are just being defined; they're not being called. Right, so a function has to be called in order to be put on the call stack. That's why when this function calls itself, we get a new copy of it on the stack, right? And it is last in, first out because, here, let's do this.
It's when they're called, that makes sense.
Right, so when we call a function, it's put on the stack. And if it calls a function, that goes on the stack. And the top function has to come off the stack before the function under it can come off the stack because it's the caller of that function. So if we go back to our non-recursive example, so it's a little bit easier to visualize, function, let's go back to our really simple example of just A, B, C, and D, right? When function C is on the call stack and function D is also on the call stack, there's no way for function C to get taken off the stack without function D being taken off the stack first because C is the caller of D. Does that make sense? So D must be completed, returned, and taken off the stack before C can complete and return and be taken off the stack. So it is the fact that D will come off the stack before C and then before B and before A. So that's why I think of it as like a mountain range or a plate, a stack of plates, right? As we put plates on the stack, those plates must come off before the top plate must come off before the next one can come off. And that also serves as a history of how we got here, right? Which was going to dovetail into errors, right? If we're in the debugger here because something wrong has happened and we're debugging it, and we want to know, like, okay, function D didn't get what it was supposed to get. How the hell did we get here? What happened? We can look and say, A called B, called C, called D, and we can actually go and look at those data we currently in this example, we're not passing any information around, right? But if this was real code and we're passing in some information, we're able to see what arguments were passed into this function's current execution, right? Because functions are declarations of a way to do some work. They're like a procedure. They exist in both procedure mode, in some sense they're just like a script, right? They're like a declaration of how to do something. They're a set of instructions, but then they're also they also get instantiated or called in some sense, and then they live in a current iteration, right? So if we go back to our recursive example, we only have one function here, but our call stack ends up being like 10 deep, because these are kind of instances of these functions, and they're all run slightly different. In this iteration, or this instance of the go until 10 function, n is 0. So we're going to do something different than this one where n is 4. Or where n is 10, we'll actually do something different, right? So the call stack is allowing you to see, like, this function was called by this other function with these arguments, and you can sort of pause everything in that snapshot and see the whole state of your application, how we got here and what variables were declared in each step of the call stack. Does that make sense? Okay, so let's talk about error handling then, and how that'll get us to the call stack. Well, let's call this I'm just trying to make something up that makes any sense at all. Okay, this is great because I just wrote this and it's not working. It's giving me undefined, and I was expecting it to give me some old shoes, right? So I said find treasure chest, which should have given me back this object, and then I passed that into get treasure, which just passed that to open treasure. Oh, I'm not returning here. There we go. Okay, cool. So here is a little bit of like fake code to work with, and we'll introduce an error and we'll work on catching it, okay? So this will be the bottom of our call stack, so at least the deepest point in our call stack, right? Because we start here we get this object, then we call get treasure, which calls open treasure chest. So if we run this again and we debug, we'll see that our first code here was our console log of get treasure passing in a chest. So when we go here, we'll see illustrated to us what the value of chest is. And we pass that to open treasure chest, which we see again. It's kind of rendered weird here, but that we can look over here in the scope that the chest again is that same object, and we just return whatever the treasure property is. Yeah? So what happens if we pass in treasure? Is that even how you spell treasure? I bet it's not. Okay, so then let's say we pass in nothing to get treasure. We should get an error. We're going to get an error that says can't read property treasure of undefined. So let's look at this error. This error was thrown. We didn't throw it, but it tells us what happened. It gives us a little bit of a history. And the way it gives us a history is by, well, it gives us a message, which is nice. It tells us what describes what the error was. And then it says that error came from open treasure chest, which was defined in the try catch example file, line 2. And then it tells us that method was called by this, or excuse me, that function was called by this other function, which was defined on line 6, which was called by some code on line 15. So it gives you a backtrace. And a backtrace is a snapshot of the call stack. So when an error occurs, the program says, okay, an error happened. This is unexpected. So I'm going to capture who called me and tell you where those things are defined to make it easier for you to say, huh, this error happened. Let me start here. I'll look on this code and see if I can reason about what could have gotten us into a case where the chest variable was undefined. We didn't expect our code to ever encounter that, but it is. So let's figure out every step of the way how we got there. Okay, so one thing I'll do if I'm debugging this is I'll say, okay, an error was thrown from this line here. So I'll put a break here. I'll just click that, and then I'll reload the page. And now, every time line 2 of this file executes will be paused in the debugger. This is a debugging technique, okay?
That's like typing in debugger.
Instead of going and modifying my code and putting in debugger, I can also just click this, and it's called a breakpoint, okay? And you'll see over here also, they'll show you all the breakpoints that you have, and you can temporarily turn them on and off and all kinds of cool stuff. This is such a great debugger. But so now, this is the first time we went through where everything's actually good. I can actually come into the console and I can say, huh, what is chest at the moment where we're debugging? And I can see that it works this time. So I'll just hit play. And now we're in it in another time. And we can see, oh, chest is undefined. That's not going to work, right? We're going to get that same error if we try to write chest.treasure. So now we want to look back in the call stack and see how did we get here. So I'll go down to our call stack here and I'll say get treasure. And I'll see here, okay, we're just passing chest through. It's undefined here. The problem must be somewhere before this. So we come back here and we say, oops, we forgot to pass in an object, or, you know, I'm making this up, but you can see how we are walking back and finding the source of unexpected execution code, an unexpected context or way our program is running. It was not the way we intended. This case was not coded for, okay? So what if we wanted to detect when this happened and raise a better error? We don't want this error cannot read property treasure of undefined. That doesn't tell us what's happening here. So let's put some well, yeah, we're gonna use try and catch, but we can also put a an argument validator here that would produce a better error message. So if we're gonna say get treasure, let's make sure that if the type of chest does not equal object, right, then we're going to throw a new error that says, you know, chest must be an object. Okay, so now if we run this code, Is that really on? Why is it preserving my log? Don't preserve my log. I'm going to turn that breakpoint off. God, Chrome, you keep changing everything. All right, well, here we go. Okay, so we got the first one worked, and then the second time we got this different error. And you can see the call stack is shorter, right? Because previously the error was thrown from here. And then now we're manually throwing an error from here, so we're only 2 level in the call stack, okay? So that's one part of errors, is that they're actually thrown by the language when you write code that doesn't make sense, but they can also be thrown by you when you need a condition, okay? So let's try to catch this. Let's come down here, and we're going to put a try around here, and we'll say catch whatever the error is, and then we'll console log error getting treasure, and then we'll console.error the error. And let's do this same bit of try and catch for the one that we know will work.
You need to close your try blocks.
Huh?
You need to close the
Thank you. I do need to close my try blocks. Okay. So we're going to try to run this code, and if there's an error, we're going to log it, and we'll say treasure A and then treasure B. And then this one's actually going to throw an error, so we're going to catch it, and we're going to log it. So the first time the try catch doesn't catch an error, and everything works as we expected. The second time, error getting treasure B was logged because we caught that error, and then we actually just logged the error using console.error in like a nice way. So it looks like this error was actually bubbled up to the top, but it's actually not. We can see that by saying good, no errors. If there's ever an error that happens in this program, we'll never get to this line of code. So I just wanna, I'll actually use console info so we can see when we actually get good, no errors. Question.
I've seen both console.log error and console.error the error.
Yeah,
And what's the difference?
I'll show you. So if we just use log, it's gonna look like this. And if we use error, it's gonna be red. And that's different in the Chrome developer tools, and it's different in Node. Console.error is just meant to display errors a little bit better than if you had just logged them by hand. It's just it's aware of this object being an error and the fact that it has a message and a call stack, and it's going to print the message and the call stack. Whereas if you just said console.log and then let's say we pass the error here at the end, we're just going to get this text tacked onto the end. It's not.
You can't click on it. You can't click
Oh, you can. It's smart. You can, but it's different in Node. So the use of console log versus console error, it's not a big deal. You can read about it, play with it. It's not. We're running out of time, so I don't want to cover that. But let's make sure that we're talking about that we're seeing how try and catch is working here. So, does everyone see how when this error happens, it is caught, and we don't have to do anything with it. We can just say ignore it, right? So what try and catch is going to do here's a little bit of a different example. Let's say we have an add 10 function that takes some number, and if the type of the number you gave me does not equal number, I'm gonna throw a new error saying number or add 10. Let's see, argument given to add 10 must be a number. Okay, otherwise we're just gonna return number plus 10. Okay, everybody, any questions about how this thing is working? So let's try it by hand. We're gonna add 10 to 66, and we should get a log of 76, right? But if I were to try to add 10 to like an array, we're gonna get that error. Yeah? Okay, so here's a good example of why we might use try and catch. Let's say we had an array of numbers and we wanted to add 10 to all of these numbers. Okay, so we could say numbers.map add 10. And I'm just going to log numbers, and then I'm going to log what the added 10 version is. And we can see each number we added 10 to, okay? But what if some of the numbers in my numbers array weren't numbers, right? So if we came in here and just made this a string, now we're going to get that error. We don't get to do the rest of the work because one of these is bad, so it threw an error. So right in the middle of our map, everything just blows up, right? So what if we change our map to do something like this? We're going to take this number and we're going to say try to add 10 to this number and just try to return that. And if that fails, we're just going to return like the error message, or let's just return, yeah, we'll just return the error message. Okay, so now, because we've used try and catch, we get to keep going. We get to keep doing our work. We get to encounter one of these items that's messed up and rescue from that error, right? So we have decided that if add 10 ever says we gave it invalid or fails for any reason whatsoever, instead of our whole program failing, right, we're just going to rescue from that. Maybe we'll just return, you know, bad number or something. Whatever's the appropriate way to rescue from the error that we have. So that's a reason to use try and catch, is when you're like, I'm doing something, and if it fails, I know how to rescue from that.
And you would rethrow from the catch block. Is that called rethrowing?
Right. So, okay, great. Thank you. I knew I was going to forget. So let's say we only want to rescue from this error. There must be a number error. Okay. So there's a couple of different ways to do this, but the one I'm going to show you is we'll just say, does the error message equal this error message? Is it this error? So if it's this error, we know how to rescue from this error, so we're just going to return bad number. Okay? But if it's a different error, we don't know how to rescue from that, so we're going to rethrow that error. Okay? That's not going to happen in our case because we're not throwing a thing. But let's say there was. How do we make up a case here? We could do that. So sure. Let's just say. Let's say if number happens to be greater than 100, then we'll throw a new error called you suck. Right? So now. If we encounter this other error, but this isn't what I want. This isn't the important part. Let's just pretend there was some other problem, right? And that we don't know what that is. Ignoring that line exists, it would not be rescued from, and we would rethrow that error. Okay.
Number greater than 2, so it actually breaks it out. It doesn't finish.
Actually breaks it out.
So it actually like doesn't get caught and does end the program. So you see like what happens when it's not being caught there.
If I put it greater than 2, I think we're still going to end up getting a you suck, right? But I mean, obviously none of them are greater than that, so we won't get that.
I say it's like, so it doesn't get caught by is this error especially handled, or it still breaks, still passes it up.
That's exactly what I'm trying to show. Yeah, exactly. So now let's take this code that's inside this log statement, and we'll say try, and we'll say you know, bigger numbers, and then we will try to console log these bigger numbers. So now I'm putting another try catch block out here. Cool. So the outer try catch block caught the you suck error. So think of the call stack now, right? So let's put a debugger right before this condition here, and we'll look at the call stack. So we first started from numbers.map, which called our map iterator function, which called add 10. And is the very first number greater than 100? No. Okay, so yeah, we have gone through a few iterations. And the iteration that we're at now, the number that was given, if we look in the scope, is this number here, which is why we're in the debugger. But look at the call stack. If we throw this error, we go up one place in the call stack and we happen to be inside a try catch. So that's going to catch this error. If that error wasn't here, or if we rethrow it, which we're gonna, we go up the call stack again. And now we're in this outer try catch is going to catch this error. So when you throw an error, or when an error is thrown in your program, that error is going to walk up the call stack until it finds a catch, a try catch. And if there's never a try catch in the browser, it's just going to log that in the console, and it's going to cause the rest of the code in that scope or in that block or in that iteration of the JavaScript event loop to not go anymore, and then we'll go to another loop. In Node, it might cause your program to exit, depending on if it gets all the way to the very top, it's going to cause your program to forcibly exit. Cool. Yes.
The thing that like really helped me grasp this was to think of all your code as running in a try catch, where it's like
sure.
if you don't catch it anywhere in there, then in order to keep the entire system from crashing, there's like a try catch in there so that your code doesn't run anymore, but it'll catch it, give you the error, and continue doing whatever else it's supposed to do instead of crashing the entire system.
Totally.
So that really helped me like understand why is it not running my code anymore and giving me this thing that's still able to operate as a computer. And also why you can do that deeper here. It won't run anything past where the error was thrown, but catch it somewhere else and still be able to function.
That is all correct. And everything we've talked about today around try-catch and the call stack is all in the context of synchronous code. There still is this next layer of complexity where not all the code we write in JavaScript is going to happen in this frame synchronously. Some of it's going to happen later, and try-catch cannot catch errors that happen later. So when we talk about doing a query to Postgres or doing an HTTP request or reading from a file using the asynchronous way we should be reading files, phase 1, we don't need to be worried about any asynchronous code. But when you get into the asynchronous code in phase 2, try and catch you're going to need to use different tools to catch those errors. There's other patterns, both within callbacks and promises, that are a way to deal with asynchronous errors, which is all of this try-catch is all synchronous errors. All right, we didn't get to everything. What do we get? Cool. Let's bring these to the next one.
Mm-hmm.
Yeah? All right.
Let's just quickly go back to the page that have that try catch on and go down. Okay.
This is all going to be uploaded, so you can check out the video in a couple hours. All right, thanks, everybody.
Thank you.
Thanks.